In today's session, yeah, thanks for your confirmation. Okay, so in today's session, we will cover what is data modeling and what is a relationship and how to define or create relationship between tables. Previously, you learned how to connect to various data sets using Power BI, and also we have seen how to use the Power Query editor to perform, how to perform reshaping the data, how to clean the data, and how to do the transformations, right? The basic transformation to intermediate level data transformation. How do we do that? How to perform group by, and what is query parameters? All those things we have covered so far. Now we will take a look at what exactly data model is all about and why we need to learn the data model. Because as part of the Power BI, you need to learn the data model part also. One way it is good because it will add a feather to your cap. It will complement your skill sets. For example, if you learn to learn the Tableau or ClickSense, you don't have to learn the data modeling part. When it comes to Power BI, you should be knowing what is data modeling is all about, because we need to create the relationship between the tables explicitly when it comes to data model, when it comes to Power BI. Though Power BI does the automatically deducts the data modeling everything, still it is important to understand how to create the relationship between the tables. Sometimes, even though it deducts the relationship automatically, sometimes due to some naming convention, some wrong naming convention or the proper naming convention or not been used, what will happen is the relationship will not get created. Okay, so the without having the proper data model design in place, if you create the report, it will not show the accurate or correct results in your visuals. So hence, it is imperative to learn the data model. Okay, so now we'll take a look at what exactly the data model is all about and why we need to do the data model design, and what is cardinality and the different types of cardinalities, which is nothing but the relationships. We'll take a look at it. Followed by that, we will take a look at what is data warehousing, data lake, and star and snowflake schema. As a business intelligence, as a data analyst, you should be knowing all these concepts: data warehousing, data lake, star, and snowflake schema. Knowing just the tool alone is not sufficient. It is not like an Excel tool, the Power BI. Okay. And also, we'll take a look at the active and inactive relationship. If time permits, we will continue with these topics. Uh, okay, now I'll jump into the first part. What is data model? Data model is like blueprint. Before you construct a house, you need to have the solid blueprint in place. Without having the solid blueprint in place, once you construct a house and later on, if you think you need to keep some additional provision, what will happen? It can leads to uh, it can leads to may altering your house, right? Later point in after construction, that can leads to more cost and more time and effort, and also it can cause significant damages, especially if you live in a apartment. What will happen? Let's say you are living in second floor, you did not keep special provision, or you did not keep a tap in your additional tap in your kitchen. What will happen? You are gone. Okay, so but you need to break everything from the first floor to or top floor to your floor, right? So hence, data modeling is like a blueprint. Before you construct a house, your blueprint should be you need to have the solid blueprint in place. Similarly, before you build any application or any web application or any software, your data model, you need to have this strong or a solid data model in place. Without which, if you construct if you develop your application, it's something like without having a blueprint, you constructing or something similar to this, right? It is cost wise. Later point in time, if you wanted to rework on your model, let's say, before, just before deploying your apps on your production ground, if you realize there is some problem in your data model design, it will involve sometimes, right? It will involve major rework. Hence, your data model should be a solid one, okay, the design. And why should I use a data model? Because once you have the proper data model in place, the exploration will be faster, and your reports will, the data in your reports will be accurate, and your aggregations are simpler to build. And reporting, writing reports takes less time, and reports are easier to maintain in the future. That is the advantage of using the, designing the data model. Okay, before you start develop the reports or dashboard, you need to have the solid data model in place. If the data model is also not designed properly, it can also cause serious performance related issues. Even though your dash queries are written optimally and you did a lot of tuning, everything, but still the data model was not designed. The relationship between the tables were not designed properly, or the optimal or the required number of tables were not included, right? It will cause some kind of performance related issues. So there are three types of data model as part of the software development life cycle. The SDLC, right? The common software development life cycle is starts with the requirements phase. In the software development, the first phase is requirements phase, and then you have something like high level design and low level design, and then you have something like cut phase, coding and unit testing. Once you develop your report, you need to do the unit test, everything, and then it will be migrated to QA and so on, and finally it will be moved to the QA and UAT and the deployment. Requirements to deployment. Okay, this is called your full development life cycle. Not necessarily you have to involve from the top to, from the first to end. Okay, and some the developers will be onboarded as part of the cut phase. Okay, the high level design, everything, the senior people, they do it. During the development phase, they will give you the document. They will help you to come up to stay speed in terms of understanding the requirements and everything. They do some kind of knowledge transition. They'll give you some kind of training, okay, and about the requirements, everything, and then they expect you to develop the reports as per the, as per the stated needs in the requirements document, or okay. Now as part of the high level requirement stage, as part of the requirement stage itself, or at the end of the requirement stage, they come up with the conceptual data model. Okay, so usually what will happen is, in a typical the offshore model, on-site offshore model in India, we have a team, and from our Indian company, one guy will go and work out and work out of the American companies. Okay, so that is our on-site. Okay, for example, Walmart, if they have outsourced the project to TCS, the project team members are sitting here, 10 people are there here, and plus one manager. And on site from TCS, at Walmart premises, he will be working along with Americans, and also he's the one point of contact for the offshore team. So this guy, he's the one talking to all the business stakeholders, understand the requirement, the respective business stakeholders, okay, and then understand the requirements. And then at the end of the requirements phase also, right, he will come up with the conceptual data model. This conceptual data model is an abstract model. It is a preliminary step wherein we define what entities the database should contain. What do you mean by entity? The tables. What are the tables that are required? Okay, right, and also identify the high-level business relationship between the entities. They will try to understand that on-site lead as part of the conceptual. This is the first phase, right? When it comes to data model, the conceptual model, and as part of the conceptual model, for example, in the case of grocery business, you want to, you are discussing with the customers, the senior management or the managers from the customer side, and as part of the requirements phase, during the discussion, you get to know what are the tables that are required. as part of the conceptual data model. So while talking to them, you get to know the customers places orders, and products appears on orders, and finally there is a cardinality. What is cardinality? It is a relationship. When it comes to Power BI, it is called a relationship, cardinality. The interview, they'll ask you, what is the, can you tell me the cardinality? What is a cardinality? Cardinality is nothing but relationship. How these tables are interacting with each other. What relationship this table has with, this table. For example, a customer places zero or more order. Zero or more order. Let's say, we have 10,000 customers. My customer base is 10,000. Not necessarily every day all the 10,000 customers should order it. Some days they order it, some days they don't order it. That's the reason I mentioned zero. Customers places zero or more order. So order is placed by one or more customers. When it comes to order, at least one customer should have been ordered, right? So one or more customers. This is the kind of relationship we will get to know while talking to the business stakeholders, the customer side, the American side, the Walmart side, the department people. When you talk to them, you will get to know that. Order is placed by one or more customers. Products appear on zero or more orders. Like I said here, so the company might sell, let's say, 10,000 products. Not necessarily all the products should have been purchased, right? All the products should have been sold. If you take 1 week sales performance, not necessarily all the customers would have purchased in the last 1 week. There are some customers they would not have purchased at all. There are some products that would not have been purchased in this week. So these are the relationship, the degree of relationship. Okay, the customer places zero or more order. Order is placed by one or more customers, and again stores, right? But stores, when you take stores, right? The stores customers are ordering from different stores, right? Each store, at least one order would have been raised, one or more order would have been raised. Each store, one or more, definitely one order, at least one or more orders would have been raised. So these are the information you will know. What tables, which is nothing but the entities. What are the entities? Entities are called tables, and how it is related with one another. You will get to know as part of the conceptual data model. You need to, as a, let's say you are on-site lead, you are working with Americans, you should be knowing, you should get all these information. So what usually we do is, once the requirements phase is over, as part of this, we come up with the conceptual data model. Then we document it, and including the relationship, business relationship, the degree of relationship between the tables, and we share it with the customer for sign off. They go through the document and they say, no, these tables are fine, and you need to include another table. Okay, something like we have something called location. A location table is not there because we operate a retail chain across different locations. You need to include that one. So, okay, include that location table. We cannot store all the data in a single table. It doesn't make any sense. Like in our kitchen, do you guys keep all the items in a single container? No, right? For you people to identify the different items in a different thing. Only when you keep the items in a different thing, like a chili powder, and you have some other powders, right? The salt, everything, you keep it separately. If you mix it everything, what will happen? By keeping it, it doesn't make any sense. The same principle is applicable. We don't keep all the data in a single table. Remember it. Logically, the data will be stored in, the data will be stored in appropriate tables. Okay, in a different tables, all the customer related information, including the customer key, customer first name, last name, and yes, maybe it's date of birth, or and then the active status, like whether the customer is still active or inactive. All the info, including address, the shipping address, everything will be available here. Okay, and products will have product related information, product name, and the unit price and reorder level. All those things will be available here. And categories, high level categories. Let's say you, in our company, In your grocery store, you sell products under 10 different categories that will be available here. Got it. So we keep the data in different tables so that accessing the data will be faster. Like the food thing, right? If you keep all the items in a kitchen, everything in a single container, if somebody is asking you, if you and everything will get messed up, right? If you keep it everything, your salt, oil, everything, you keep everything will get mixed up. We don't want that to happen. In order for us to easily identify where the chili powder, where the right? Similarly, so where the product information, what is the cost price of each product. If you wanted to understand, you can access this table, you can get it. And if I wanted to know, what is the profit? So in that case, orders and products, you join it. Here you have the cost price. Here you have the listed price, and with that, you will get to know what is the selling price and what is the cost price. And when you subtract this, you will get to know the profit. So logically, and also the performance will be faster by keeping the relevant data in different tables. It will be faster. And again, with the help of the relationship, we can filter the tables by defining the proper relationship between the tables. It helps us to filter the data from the tables in a pretty fast manner. So the next one is, after the conceptual model is over, next phase is logical data model. As for the design phase, as I told you here, in the software development life cycle, the second phase is going to be your design phase, high level design, low level design. Sometimes we keep only one design document, depends on the customer. As far as the design phase, we come up with a logical data model. Not only identifying the entities that are required to build your reports are sufficient, we need to know what attributes, what are the columns each table should have in it in order for me to create the reports. When I spoke to the marketing team, they need so and so columns to be displayed in the report. When I discussed with the VP Finance, he needs the report and it should capture so and so information in it, right? So columns. So hence, it is imperative to we list out, right? We identify all the columns or attributes that belongs to each table as per the logical data model. Okay, and the business rules, like the customer entities have at least one unique identifier, and the product table, at least it should have one unique identifier. And the customers and products, categories and stores, these are called dimensions. It is also called as a lookup tables. This is kind of a transaction table. It captures each and every event. Okay, each event, it will store the events of every transactions in it. For example, you order a product today, and like you, hundreds of customers, they order all the customers, orders related data will be there. It'll have the entire transaction data. For example, in the case of Walmart, on an average, every 1 hour, 1 million transactions are generated, 1 million orders are raised. So 1 million orders related data will be there every 1 hour. If you see, right? So 1 million, 24 hours on an average, 24 million records are there, something like that. Okay, it will be there. The detailed transaction related data will be there, but customers table and products table, as and when the customers sign up in their the website, there in the case of e-commerce, okay, their customer information will go here. And in case of the seller, let's say like Walmart or Flipkart or Amazon, sellers can go and sell their products on Amazon, right? So you in that case you will have another table called sellers. In the case of email, you need e-commerce, okay, you need to have additional table like a seller's information, their address and what products they sell it, everything. And products, whatever they list it on Amazon to sell it, that product's data will go in here behind the scene. Okay, and automatically, right, while listing out their product, they need to key in the product name and images, everything. They need to upload it along with, they need to specify categories. But behind the scene, the data will get loaded in the appropriate tables according to the seller. It will appear one single screen, but behind the scene, the data will get stored, splitted and stored in different tables. Or it will get organized into and stored in a different table. So as for a logical data model, we identify the attributes that belong to each tables, and also we understand the business rules, like which keys are primary key. Here category key is a primary key, store key is a primary key, and but when it comes to order fact, you will have the composite key here. Okay, and those kind of things it will have in it. Okay, and also we identify the relationship between the tables. We define the relationship between the tables as part of logical data model. So these are the notations that they use. It we have something called ER model. ER model. When you join any company, right? So you need to first ask, can you please share me the ER model, entity relationship model. So that you will get to know which columns are available in which table. Okay, and what kind of data model is that? Is that a star schema or snowflake schema? We'll discuss this little later. Don't worry. Okay, and you will get, you will need to ask this document. Okay, so this is important. Okay, you have every right to ask them. Okay, because you are a report developer or data analyst. You are going to build a report or dashboard, right? You should be knowing that, especially when they use multiple tables like this. So these are the notation they use it as part of the entity relationship model. For example, if you see something like this, 0 or 1 product. Like I said, customer would have placed a 0 or more than one product or one product, and some cases 1 to 1, like Aadhaar number. Or a company can have a CEO. A CEO can have only one company. Something. This is the notation they use it: 1 to 1 relationship and 0 to 1 relationship, and this is 0 to many relationship. Um, a customer would have placed a 0 or many orders. Star is many, 0 is nothing. And this is the crow fit, right? Followed by the crow fit. If you see 0 means 0 to many, and followed by the crow fit. If you see 1 to many relationship, that is what the notation says. Once you get that, you will get to know that. Apart from logical data model, the next phase is physical data model. We have something else called physical data model. The physical data model, we define the data type for each column. Customer key is, for example, it is going to be an integer data type, and first name is something like varchar, character data type, varchar of 20. Likewise, we define the data type and the width of the data type, width of the column, right? So data type and width of the column, everything we define it as part of the physical data model. And again, once the physical data model is ready, we share it with customer, we get their final approval. Once they sign off, yes, everything is correct. And some cases they'll say, no, the width they need to increase is 25. Some customer first names are very big, you need to use 25. In some cases they say, make it 20, this is enough. After you get this reviewed, the physical data model with your customer, then you are good to start with your development phase. Okay, this is the data modeling process flow, at a high level. Okay, identify the tables or entities that are required to create your report, and then identify the key properties, nothing but the columns that belongs to each table, and then identify the relationship between the tables, and then map the attributes to entities completely, and visualize the data. And after visualizing the data, if you think, in order to do some kind of filtering, it needs additional keys, then you need to go and check it and then finalize it and vet it with your stakeholder. Share the document with the customer. Finally, if they review it and if they give comments, anything, you can include it, and that's it. Okay, now the next question is, I'm going to skip this. This is not required at this moment. Now the question is, why do I have to do all these things? Conceptual data model, logical data model, and physical data model. Who is responsible for this? Is that a responsibility of a data analyst? Some cases, yes, but nowadays, yes. It depends on the customer. Okay, so there are cases, they already have the data warehouse. Customers, they would have done all the data model design, everything here. Okay, it's a database. Data warehouse is nothing but a database. Okay, the term is different. Database. There are two types of database. One is OLTP, the other one is the data warehouse. But both of them are database only, warehouse. But here we store the historical data. But here it is not like that. We don't store the historical data. Maybe 1 or 2 year data will be less duration of data only will be there. Okay, but whereas here they store the historical data. Only when you have the historical data, you can do analytics. But in the case of data, some companies, they already build the data warehouse. It's a very expensive thing, setting up a data warehouse. Okay, especially with the larger enterprises. And the data warehouse will have all the data in it. Already they would have done the data model design, everything. Then you don't have to do anything. But still, as a report developer, you should be able to understand the design, the relationship between the tables. Only then you will get to know how to navigate from one table to another table. So in the case of Snowflake schema, if you want to get if you want to do some kind of the top of the hierarchy level data, if you need it, you need to know how many number of tables you need to process it, how many number of tables you need to navigate in order to get your uh, the top hierarchy level data. Okay, anyhow, we'll discuss this later. So the at this moment, let's assume that the data warehouse is already built by someone else. It has historically, the data model, everything is in place. But still, you need to ask them to give the ER model, entity relationship model, in order to understand the data model design. If you are going to be part of a new development project, one way it is good, though the duration will be more and the effort is more, but still, once you master it, as per a new development project, everything, right, from the each and every phase, then you are all set. At least to complete end-to-end life cycle, if you involve it, then it makes your life simple, right? And then you can gain more exposure. Okay, in the case of new development, yes, you need to do the data model design, everything. But is that the responsibility falls on a data analyst? It depends on the company. They may expect you to do the data model design, or they will have something called data architect, or the business analyst, business analyst. They are the one will help you to create the data model. It's not that one-man job. So it will be like sometimes the if they have an data architect, it is his responsibility. We don't have to do any data model design. Only thing is we need to understand how the tables are linked with each other. And but if they don't have a data architect, then along with the business analyst, you will be developing the data model design, and everything will be doing it. Okay. But if the data warehouse is already there, you are all set. You are all set. Okay. And you need to understand the model thing. You don't have to design the data model. Fine. Okay. Now the question is, first of all, why data model is required? Why we need to do the data model design in Power BI? Why we are not doing the same in other tools? Why it is so special in Power BI? Only then Power BI will work if you do the data model design. Otherwise, it will not work. For example, I just show you one example. You should be able to understand with this. I just go to the. So we are going to spend time in this one because we are talking about the data model design. So now we are going to look at only in this place for some time. So here, the moment right after you load the data into your Power BI desktop, and when you switch to this mode, the model view mode, you'll find something like this, right? The tables and the links, the lines between the tables, everything you can see it. These are called relationship. It is also called as a cardinality. The cardinality has two meaning. The one meaning is a relationship. Other one at this moment, let's not worry about. It's kind of a unique value. Okay. Fine. So these are the dimension tables, and this is my fact table. Forget about dimension fact at this moment. These are the tables, and each table have columns in it. And we can see the line between the table. These are called your relationship. Okay, now I have, look here, if you see here, I have a location dimension and then the sales fact. Okay, I just go and select, create one report here. Now we want to understand why data model is required. For that, I just show you an example. With this, you'll be able to understand why we need a data model. Look here, location name. I just drag and drop it here. This is just a table visual. Look here, I just clicked on it. It got dropped here. And next one is we wanted to, let's say my manager wants to see location wise sales performance. That's it. And the font size are not good. Okay, I just increase the font size. Okay, now it's visible. So here you can see the location name and sales amount. The location, when you select this visual, it gets highlighted. With that, you can make sure that which visual you are working on it currently. If you have multiple visual, which visual, sometimes if you don't want it, you can click on the empty place of this report canvas. So nothing got selected. Now you are very particular about this. When you select this one got highlighted, right? And on the right side, just beneath the fields, you can see that the table name and the associated field name, which we used it in this visual, will get highlighted. Look here, sales fact table. In the sales fact table, we have something called sales amount. That is the one we used it here. But you can see it here also. You can see it here also. Okay, you see the actually we are supposed to drag and drop it here. There is another alternative. You can drag and drop it directly onto the visual, but this is the proper way of doing it. Since I just used only the two columns here, I just dragged and dropped it here. Fine. So now with this, we can understand two columns. We have used it in this visual. Fine. But these two columns comes from which table? That one gets highlighted, with this tick mark. So the location name comes from location dimension table. The sales amount comes from sales fact table. This one comes from location table. This one comes from sales table. Got it? So now what I do is I just go to the model view, and location and dimension. We have one-to-many relationship. On the, just next to the location, you can see one. Just next to the sales fact, you can see this star here, which means one-to-many relationship. Got it? Now what I do is I just keep the cursor on top of this line. I just hover the cursor here. Location key and location key got highlighted. So with that, you are able to understand these two tables got created. The relationship between these two tables are created based on these two columns. Location key on your dimension table, location key from your sales fact table. With these two columns, common columns, it creates the relationship, but it is a one-to-many relationship. Okay, so far so good. So now I just right click on it and I delete the relationship. Are you sure you want deleting? Yes. And if I go here, you see here what you can see here. The overall total was 456K. The same value gets repeated across the rows. Why? Because this location dimension table, this table was not able to filter the sales fact table since I deleted the relationship between these two tables. Now we understood how important creating the relationship between the tables. Okay, it is necessary that you have to create the relationship between the tables. Otherwise, it will not filter the data here. I just go back here and I'll show you again how to create the relationship. Okay, you remember this number. This is the total sales, all these location put together. But it is not giving the split up for for each location. Ideally, Bangalore, what is the total sales we made out of this overall total? That is what it should show here. It is not showing that. It is repeating this overall total for each location because I removed the relationship. Relationship is very much important. I just create the relationship once again. How do I create the relationship? Listen very carefully. So here I have the location key. Here I have the location key. There are two different ways you can create the relationship between the tables. So now you can either drag and drop this column on top of this column. Okay, location key and location key. If you drag and drop this here, it'll create the relationship. The other alternative is you have something called manage relationship. Just click on this. It will open up something like this, the dialog box. Here you can go and click on new. Now I want to use the location dimension table, and the next one is sales fact table. The moment when I selected the dimension location sales fact, you can notice one thing very clearly. The location key in both the tables this column got selected automatically. You can also change it, but you know very well, in this table, location and this location key table values are same. In order to create the link or the relationship between the tables, you need to have the common column between the tables. So we don't see the location name here. Okay, only the location key is there. Location key and location key. These two columns are common. With this only, you should be able to create the relationship, because in this table, the location key is the primary key, whereas in the case of sales fact, this location key is the foreign key. There is a one-to-many relationship, which means in the case of dimension location, for each location, only one location key will be there, unique key. You cannot have the duplicate of the Bangalore here. Again, you are not supposed to be a law. The location key should not be repeated more than once in the case of dim location. Whereas this is a transaction file, right? It can have multiple values of BLR here, Bangalore, Pune, and all. Because the transaction, because in Bangalore, you would have done 1,000 transactions, right? So 1,000 orders would have received it. So hence, each time to know, right, each record to know this order is placed from which city, you need to have the location key here. But location name will not be there here. Got it? Location name is available. If you want to get the location name, you need to join these two tables, and then you need to get the location name. Okay, that we will discuss it later. Let's go step by step. So now we want to create the relationship. Click on OK. The common column between the two is location key. Okay, selected. And then I click on OK here. And you can see the first one from table, dimension, location. In this table, location key column, we used it. And then in the sales fact table, we have used the location key column, right? With this, we create the relationship. It is an active relationship. I click close. And if you see here, magic, look here, a line got created. To make sure that whether the relationship got created between these two tables with the correct column name, keep the cursor on top of this. You can see that location key in both the tables got highlighted. The next question is, okay, the naming convention of these two columns should be same. For example, you might be asking this one. Here, there's some the location space ID is there, whereas here location key is there. In that case, what will happen is, after you loading all these files into your Power BI desktop, Power BI will not automatically detect the relationship. So in this case, what happened after I loaded all the files, Power BI automatically creates the relationship. But in this case, for example, here you have order location ID is there, whereas your location key is there. Since the column names are same, it is able to identify. Okay, of course, these are the common columns. So with this window, and then it creates the link automatically. If that is the case, for example, here location ID, location key is there, but you know very well location key is nothing but location key. Okay, so what you do is you just click on manually, or simply you can drag and drop and on top of and drag and drop it on top of this column. The relationship, there is already a relation between these two columns. This is another way of creating the relation. This is a very simple one, but when you drag and drop it, you might tend to make some mistakes. In this case, we have only few tables. When you work in a real time, multiple tables will be there. You just drag and drop it. Sometimes mistaken if that gets linked with order date, the filtering will not happen correctly. So now we will go back to the report view. Now you see the magic. After creating the relationship between the location and the sales fact table, my location table was able to successfully filter my sales fact table sales amount column. And on top, the beauty is that, this is the total sales, and it gives me the split up automatically. In Bangalore, what is the total sales out of this wine? How much sales we made in total in Chennai out of the overall total? It gives the split up automatically. I did not write any tax function. I did not write any program. Simply, I just did the drag and drop. It does the magic. That is the beauty of Power BI. It gives me the split up. Location wise, sales split up, it gives automatically. But for this, relationship should be defined. Sometimes what will happen is like I have shown, when I delete the relationship, what happened? This total value was repeated. When you see something like then that, it is a sure shot that this, somewhere the relationship was not defined. Then you can go and create the relationship. Then the split will happen. Okay, so why data model? To answer to this, this is the one. You need to create the relationship between the tables. Without relationship, it is not going to the filtering. The next question is, what do you mean by filtering? Why are you using the term filtering? Because that is the one is used by many of them. As those people work on, especially the Power BI, right? They use the term filtering, and even in the internet, if you see many blogs or communities, they use the term filtering. For example, here, okay, what exactly filtering? So only when you create the relationship, see now it filtering has happened. The location table filtered my sales fact table. What do you mean by filtering? What exactly filtering? Let's take these two examples. This is my sales table. This is my country table. So in this case, in the country table, for each country, we have only one unique values here, the country ID. If I say US, it is United States. Again, US should not come here. You are not supposed to same key here, and then you are not supposed to US stands for something else. You cannot say. For example, the classicism IND. IND, India, but IND Indonesia is also there, right? But for that, you need to give different key. That's all. That's the only way out. So let's stick to this example. Okay, the country ID and country ID, these two are common between these two tables. Hence, Power BI detected the relationship, it created the relationship, or we have created the relationship by just dragging and dropping it on this column name. We are able to create the relationship. We can see the link here. Fine. And what this link does, how it is helpful, it helps us to do the filtering automatically. What do you mean by filtering? Okay, so now I created the visual here. Okay, and what happens since we have the relationship here, the moment when you drag and drop the sales amount, see initially, look here, when I drop the sales amount, only one value will be there, total sales. Because we did not tell this visual, whether I need the sales total by location or product or cut. I did not tell. Hence, it gives me the overall total. Along with this, if I put one text column like location name, look here, and now, okay, now I just move this up. This is how we can change the order of the column. For example, you want the location name should be displayed first and then sales amount. You just move this up. That's all. Location name displays first and followed by this your sales amount. Just give me a second. Somebody is waiting at the door. Give me a second. I'll be back in a second. Okay, I'm back now. So this is the relationship. So what we are talking about, the filtering. So what happens is the moment when I drop the location, it automatically filtered the Bangalore related records from the sales fact table, and then they applied the sum. And if you notice something here, once you load the data into Power BI desktop, just next to the numeric column, quantity, profit, sales, this is a numeric column, right? So next to that, if you see the sigma sign, which means the aggregation, okay, which means it does the aggregation automatically. Look here, when you click on the sales amount, you can see the summation now. If you don't want this to be done, don't summarize, you can select it, but this is the default one. The moment when I dragged and dropped the sales amount alone into this visual, the total sales amount, only the only one value was displayed, right? The total sales amount. The moment when I dragged and dropped the location name or any categorical variable along with this one, automatically gives this split up. This is called filtering. So because of the relationship, okay. So see here, what is happening is behind the scene. What happens is since we have the relationship here, the moment when you drag and drop it, what happens is you just assume that location is nothing but country here, okay, um, or a country is nothing but location, okay. So here, what will happen is it goes to the first record and US, right? It automatically selects all the US records in this fact table or sales table, and then it applies the sum because the default one is sum here, right? It applies. So it filters all these US related records. How many US related records are there? 4 and 5 records. And then it applies the sum on all these things and the 2500 and all these things. And it gives me the, okay, this, assume that this is United States. United States, what is sales? Only this sales, not the overall sales, only this sales it gives. And then it goes to the next record, and then it goes and filter the corresponding Australia related records, and it applies the sum here. So you will have only one record, AU in Chennai, or what is the total sales. And that is what it says. Because of this relationship, it does the filtering automatically. This is called filtering. It goes record. First it goes the United States, and then it filters or selects only the US related records, and then it applies the sum on the sales because we have dragged and dropped sales, right? And the next one is once the sum is over for the United States, it skips to the next record, Australia, and then it applies the sum. And same things applicable to product table, sales table, everything. Okay. Now you understand what is filtering. In order to do the filtering correctly, in order to display the values correctly, you need to have the relationship between the tables. And you need to have the proper relationship between the tables, one to many. If it is going to be many to one, this is a many to one, okay. The opposite is many one, this is one to many. Fine, now we understood the importance of the relationship, defining the relationship, and creating data model design, is very much important in Power BI. Without that, it will not do the filtering correctly. Next, we will take a look at what is data warehousing and data lake, star schema, snowflake schema,